In this example, we've got some function s of t that models the value of an investment over time. And we're given the rate of change s prime of t as a graph. Okay, so it's very important to read these carefully. This graph is the graph of the derivative. Okay, this is the graph of the derivative, and we want to find some information about the actual function s of t. So first of all, we're asked, what are the critical points of this function s of t? Okay, so remember the critical points occur when the derivative is 0, right? So what I'm looking for is when s prime of t is equal to 0. All right, so keep in mind this graph is the derivative. Okay, so I just want to look at and find where this function for the derivative crosses the t-axis, right? Where is it 0? All right, so the derivative is 0 at these points where it crosses the x-axis or the t-axis. Okay, so I can say that s prime of t is equal to 0 for t equals 1, or t equals 4, or t equals 6. Okay, so these are the critical points. These are the critical points. All right, so that answers the first question. What are the critical points? The next question asks us to identify each critical point as a local maximum, local minimum, or neither. All right, so I'm just going to draw a little, well, let's draw a little number line again, like I did before. So let me just write this. This is part B. I'm just going to draw a little number line again. All right, so I want to test points on either side of the critical points, and the critical points are at 1 and 4 and 6. Okay, whoops. 6. 1 and 4 and 6. Okay, those are my critical points. So let's take a look at the sign of the derivative, right? When the derivative is positive, the original function is increasing, right? So I can see that to the left of 1, the derivative is positive, so it's an increasing function. Okay. If I looked at the interval to the right of 1, you can see it's again positive, right? It's still positive. And so, so my function, the original function, s of t, is increasing. Now, between 4 and 6, you can see now that the derivative is below the t-axis, right? So it's negative, and so the original function, s of t, is decreasing on that interval. And then to the right of 6, you can see it's positive again, so it's increasing. All right. So what does that tell us about those critical points? All right. Let's kind of list this out. So you can see we have, when we're going from increasing to decreasing at 4, we have a local maximum. Okay, at t equal 4. I think I said x, but I meant t equal 4. Okay, so we have a local maximum of t equal 4. We have a local minimum at t equals 6, right? Because we're going from decreasing to increasing, right? So t equals 6 is a local minimum. Now, what about 1? So for t equal 1, it's increasing now, and then at t equals 1, the derivative is 0, but then it's increasing again. So t equals 1 is neither. That's right, is neither. It's neither a local maximum or a minimum. Okay. So, we can take a look at what you could kind of sketch a graph of what s of t looks like. You can kind of imagine that we're going to try to take this derivative and sketch a graph of the original function, s of t. And you can see that it looks like it's increasing And then it flattens out at 1, right? So if this is, say, 1, 2, 3, 4, 5, 6, 7. Okay, that's not very, my scale's not very good here. So let me back that up. All right, so we have a little bit of a scale here. 1, 2, 3, 4, 5, 6, 7. All right. So at 1, let's say that's the value at 1. It's increasing, but it flattens out at 1, and then it continues to increase. So we have sort of a little inflection there at 1. And then at t equals 4, so 2, 3, 4, 5, and this is 6. Okay, so at t equals 4, if we went up here to t equals 4, we would have a local maximum. So we could kind of sketch that. It looks like it would be something like that maybe. And then it starts decreasing, right? It's decreasing between 6 and, or between 4 and 6. And then let's say that that was the value at 6. So it comes down here. And then, but then after, at when t is greater than 6, then it's increasing again. So, if we were going to take the information from the derivative and try to sketch the original function, it would look something like that, right? Now, we don't know the exact values, there could be, this is just kind of a sketch of what the shape would look like. So, part C, explain the significance of each of the critical points. All right, so we kind of, by sketching the graph, you can kind of see what's happening. So at t equal 1, let's kind of work left to right. At t equals 1, it was increasing, and then it stopped increasing momentarily, but then it started increasing again. Okay, so that's how we could describe the value of this investment. So at t equal 1, the value of the investment stopped increasing momentarily and then began increasing again. All right, so let's take a look at the value of what happened at 4. All right, the value was increasing, and then it began decreasing. And then at t equals 6, it stopped decreasing and began increasing again. All right, so that's pretty much all you really need to say about that. Just describe, just recognizing that this function is describing the value of an investment, and when the slope is positive, right, then the value is increasing. When the slope is negative, the value is decreasing. All right. So that's all I have for this example, and I'll meet you in the next video.